Hello, everyone. Hello, LinkedIn. Hello, devs. Hello, folks on LinkedIn. Good morning, good afternoon, good evening, good night. Always nice to see worldwide representation today. Today, we're going to talk about a particular cloud-native deployment pain point here on Demo Days. And to help me with this topic, I'd like to introduce you to Moose, who is a field solutions engineer over here at GitHub. And we also have some additional special guests from Trilio. I've got Prashanto and Ben. Prashanto is the director of product over at Trilio, and Ben is a solutions architect at Trilio. So Moose, if you could take it away.
Awesome. Thank you so much, AJ. And actually, yeah, I got to update my LinkedIn. I'm actually now on our advanced security team over here at GitHub as a field architect. So I got to go and update that. So happy to be here today with my friends Ben and PK. Interestingly enough, I got to give a shout out to Rob and Dalton Menhall over at Trilio for helping get this together through our channels, working together in the past. So got connected a couple months ago, just kind of understanding what Trilio could do potentially, not just with GitHub but for the GitHub community as a whole. So I'm happy to be joined them. That's why we do it live, right? Be joined by them today so they can kind of show you what they has come out of the conversations. They built a really awesome GitHub action that I think is going to provide a lot of value to the community here. PK, Ben.
PK, I think you're still on mute there.
With that, so Moose is absolutely right. The joint collaboration between GitHub and Trilio has been extremely valuable. We definitely feel we have built something really intricate over here, which is going to solve the challenges that we experience, in the cloud-native delivery model. And Ben and I are going to be super happy to present everything. Show you all a demo as to how it works, what everything is built and the value that it's providing in the end. Okay, so without much ado, I'm going to put this in presentation mode and we can get started. So from an agenda perspective, what I'm going to do first is I'm going to talk about the challenge or the problem that we are solving over here. Next, we will get into the cloud native data protection platform of Trilio, and we look at the solution as to what is the technology behind the solution to the challenge and how it's powering it. After that, we will provide a quick introduction to the TVK GitHub action, the workflow or the GitHub action that Trilio has developed. And then Ben will be going into a demo showing you exactly how everything works and how we are going to solve that pain point for you. And then finally, we'll wrap it up with a conclusion. And if we have any questions, we'll try to answer those as well. Okay, so one of the most common CI/CD issues that we hear about, when we talk to our customers, is that when they are developing code, everything works well in their dev environment. They move it into their test environment. They are able to test properly, and everything works there as well. Staging wise, just before launching into production, everything looks clean. And when you launch into production, you hit a bunch of different issues. And then oftentimes you end up looking like that image on the bottom right. You are thinking about, hey, how did this happen? Why did I miss this? And when you actually find the root cause, you feel that, hey, this is something that I should have figured out earlier on, or something that I could have stopped from failing in production. Now, one of the biggest reasons why this ends up happening is because in all the other silos that we have of dev, test, staging environments, we end up generally testing with older copies of the data, or it's stale data, or random data, which is not a true representation of your production data. And as a result of that, issues that happen generally more during runtime, you're not able to address those or surface those before launching into production. So the need to test with production data becomes very, very important. Now, in order to keep our conversation and this session little interactive, we have a poll question based on the problem statement that I've just described. And what we want you to do is use the LinkedIn live chat to type in your answer. So the question here is, do you face the CI/CD challenges of passing every step until production but failing in production? And your options are, yes, you face these challenges, but you do not have a solution. Yes, you do face these challenges, but you have a solution. And then C is obviously you have this challenge, but it's really not important to you. Again, we are looking for your responses in the LinkedIn live chat, and just enter the letter corresponding to your answer. And AJ, I'm going to look to you because I cannot see the chat.
I'm keeping an eye on it too, PK.
Perfect.
So it's just actually coming out now. I can see it.
So just give them another 30 seconds to 45 seconds for folks to look at the question and then quickly enter an answer into the chat.
Yeah, no, this is definitely bringing me back to my days years ago as a DevOps engineer. I wish, yeah, definitely faced a lot of these challenges. It was misconfiguration of files, password rolled, got updated. There was control M's in the configuration file, was a popular one as well.
Definitely, yes. And I think the cloud native journey is definitely helping solve some of these problems, and we'll definitely be kind of addressing those right now.
Definitely a good smattering of answers here. Looking for the trend. Definitely a good amount of B's.
Mm-hmm.
But definitely a good amount of A's. I'm not seeing any C's really.
Great. So definitely this is
one C. Sorry.
Okay. I guess the general consensus though is that this is definitely a problem, and you may be trying to solve it in different ways. Again, and today we are going to be talking about how you solve this in a cloud native, Kubernetes native environment. Making sure that your application delivery is as fast as application development. So we'll jump into talking about the technology that is Trilio Vault, which is powering the solution and the GitHub action that we have built. So Trilio as an organization, was founded in 2013. We are already the leading data protection, data management solution for OpenStack and Red Hat virtualization environments, and now we are spearheading the Kubernetes realm or the Kubernetes journey as well. So what you see in front of you is the Trilio Vault management console, and the way we have built our product is we've made it completely Kubernetes native. So as long as you have a Kubernetes qualified environment, a CNCF conformant Kubernetes distribution, Trilio will work out of the box in it. And whatever we are showing you as part of the GitHub Actions that we've developed, they will also be supported without any additional configuration that is required. Secondly, what we've done is in order to communicate with storage or your application volumes or your persistent volumes, we leverage the container storage interface so that we can keep that data layer extremely agnostic. So even if you're dealing with heterogeneous environments throughout your development, your test clusters or your staging clusters, even if they are completely heterogeneous, Trilio will still work out of the box on them without any configuration required. And obviously, we know everyone is following a multi-cloud or a hybrid cloud strategy, so you will be running this software or the solution in multiple places, and Trilio has you covered for that as well. And then finally, what the technology supports is we are completely application centric. So what we allow you to do is capture your entire namespaces if you want to, capture specific Helm applications, capture operators themselves, like capture the operator objects, the operator custom resources, and the application that the operator is managing, all of that as one unit. And then finally, we allow you to capture whatever you want within your Kubernetes cluster via labels as well. So overall, 360 degrees makes it a really nimble, flexible solution working in any of your, deployment services pipeline. However it may be constructed, Trilio can support you in that. Now, what is it that Trilio does? We spoke about, hey, that these are the features it is capable of, being distribution agnostic, storage agnostic, but what is it that we actually provide, and how is it that we enable that protection and recovery? So at the very first level, from a Kubernetes cluster at any namespace level, we can capture all the metadata components and the data components, and we can put that in a centralized repository, which could be NFS based or S3 based. So we capture all the metadata, the data volumes, and we store it in that central repo. Now, once it is in that central repo, you have the ability to take that same data and restore it back into that same Kubernetes cluster. Obviously, you can overwrite what you had in your namespace, but you can also deploy it into another namespace as well. And what it also allows you to do is take that application that you captured and move that into another namespace of a completely separate or completely different Kubernetes cluster. So now you can visualize that this method of doing point-in-time captures and point-in-time restores, Trilio can actually, between your production environments and your dev and test environments, we can easily capture your running application and along with the metadata and the data aspects of it, bring it back into a secondary environment where you're performing your testing and validations. Now, I think it becomes very important to understand the different players within the Kubernetes system and how they would be using this solution of Trilio Vault, as well as the GitHub Actions that we have developed as part of it. So on the extreme left, we can think of the persona of Lisa. Lisa is the developer who is, 80% of the time writing code, building microservices, and focused on developing the application. And her main challenge again is to ensure that she can test with production data, so that she can enable or increase the success of launching or delivering software back to customers. Now, Lisa works very tightly with Brian. Brian is the SRE. He works with Lisa to take the microservices that she has built, run it into the run it in the Kubernetes system, and making sure that it's it has uptime, it's continuously running. From a monitoring logging perspective, you are making sure that it is providing all those metrics and stats. And again, the main thing that Brian is also concerned about is making sure that when he launches this application in production, it is successful and he doesn't have to keep retweaking and rehashing and fixing issues that could have been caught beforehand. And as we move from the development side to the ops side, we have Rob. Rob is also, you can think of him like an SRE from the ops standpoint, who is building all these clusters for the dev teams to play in and develop their code and run their applications in. Now, Rob's intent is also, he's looking at everything at a macro level, right? He is looking at all these namespaces together, and he wants that easy button or that easy workflow to restore everything in case a disaster happens. So he's thinking more in terms of disaster recovery. Obviously, if any kind of corruptions or security breaches happen around ransomware, recovering from those are the different activities that Rob is looking for. And then finally, looking or going deeper into the ops side, we have Jane. Jane, you can imagine her to be the kind of like the IT director who is focused on cost related items and focused on business continuity, because of which migrations of applications become very important and near and dear to. So overall, this is how the personas within a Kubernetes system interact with each other. And obviously what they do is they leverage a lot of infrastructure as code, right? Their infrastructure as code is placed within the Git repository itself, so in GitHub. And they not only have Lisa's development code over there, Brian's deployment code, and Rob's deployment code for deploying the clusters, but also the application and how it's built. Everything is kept within Git. And obviously there are paradigms like GitOps that Lisa and Brian are using to deploy everything or the applications into the cluster. So our focus for today's conversation and what we have built the TVK runner for is going to focus on the day zero aspect of Brian and Lisa working together and ensuring that they are able to deliver software successfully and with as minimal of issues as possible. Okay, with that, I'm going to start talking about the GitHub Actions runner that Trilio has built. So I'm going to start off from the left-hand side. That is the developer laptop. You can imagine someone writing code and checking it into GitHub. Now, within GitHub, you have the concepts of workflows. Workflows, as the name suggests, is an orchestrated pipeline of performing certain tasks. And as part of the workflow, you leverage the runner that Trilio has built. Now, this runner basically has a source configuration and a destination or a target configuration. What that runner basically does is, once you check in code, first a backup job gets triggered. And as part of that backup job, the TVK runner will go to the production cluster, which is the source cluster, capture everything from there. So let's suppose you had a MySQL database running in production. We will capture all the metadata and the data objects, get it into the centralized repository. Then the second part of the workflow would be the restore job. And what happens in this stage, the runner again takes that copy of data that you had captured and brings that into the destination cluster. So what happens is, as soon as your code has checked in, on one side, you are running your integration tests, making sure that all the code can be packaged into a container image. And while that is happening, you are also fetching your production data and bringing that into your test environment, so that once your CI tests pass, it's ready to run against that newer copy of data that you have just brought in. Okay. Now, there are obviously other items also that Trilio provides as features. So for example, if you need to anonymize the data from the production side to the destination side, Trilio provides a lot of hooks which can be injected into the runner itself, so that you can talk to your MySQL application, anonymize a column of the table if you need to, and then bring it into your dev and test environments. So all those granular capabilities are also available. Lastly, when you have multiple clusters, it's always possible that you are running different storage classes or different storage types in your production environment versus your test environment. What this runner also allows you to do is, on the fly, as it is moving that production data from the source side into the destination side, we also allow you to change the storage class on the fly when it gets restored. So again, talking about that heterogeneous aspect, fully agnostic, no matter what kind of environments you're coming from, you will be able to do this, day in, day out without any issues. Okay. So now I'm going to hand it over to Ben to basically put the rubber to the road, and whatever I have spoken, show that in action as part of a demo. Okay, and Ben, over to you now.
Okay, thank you, Prashanto. Can you see my screen and the Lens terminal up here?
Yes, we
I
can.
can. Yep.
Good to go. Sounds good. So we're going to do a demo today showing a backup and a restore from one cluster into another cluster using that GitHub runner. And so we have two clusters here. Our first one is going to be a Rancher cluster, and this is going to be the source cluster. And then secondly, we have our GCP OCP cluster. This is OCP running on GCP for our target or destination cluster. So first and foremost, as Prashanto said, our GitHub runner is running in our source cluster. So you can see this example runner we have here using our repository Trilio demo, Flux demo, and it is up and running. The application we're going to be migrating over from one cluster to another today, backing up and then restoring, is going to be a MySQL application. So here you can see this was deployed about 17 days ago, up and running, 1 out of 1, all is good. We have 3 different front-end pods and a back-end MySQL pod running. We have 2 different services here for the front end and the MySQL. We have 2 different deployments for that front and back end. And then we have these 2 replica sets, all 3 out of 3 and 1 out of 1, good to go. We also have here a PVC associated with this MySQL database. We're bound and good to go. And you'll see that is using the storage class of EBS storage class, EBS-SC. And then lastly, we're going to show here that there are no backups that have been taken yet of this application. The Trilio runner, once it starts its workflow, is going to take a backup here in the source cluster and then restore it into our destination cluster, this GCP cluster here. So now it's to show you that none of these, that the MySQL application is not running here in this space, as long as I did my homework correctly and made sure I removed it. We'll see no resources in this namespace. There we go. There will also be no PVCs. And there will be no restore that has occurred yet in this destination cluster. So now switching over, we're in GitHub here, and we're looking at that Trilio demo, Flux demo repo, where our workflow is sitting to use that GitHub Trilio runner. And so we have a few different files we're going to look at here. First, we'll look at this source kubeconfig. As you can see here, it's that same RKE cluster that I showed you before for the source cluster. And we just have our kubeconfig in here so the runner knows which cluster to be pulling from. We then have our destination kubeconfig. You can see here Ben GCP4, that same GCP OCP cluster that we were using before for the destination that had none of that MySQL application running in it. And then we also have our environment variables here. This is where we're going to see what target we're going to be using to back up that backup to, store that backup to, and where to pull that backup from in the case of the restore. We also have the namespace where that target is sitting on this source cluster here, and then the backup namespace where the backup is going to occur on that source namespace, which is that bend demo namespace. And then the destination cluster, we have again the target we're going to be using, the target namespace on the destination cluster, which is demo restore, and then the destination namespace on the destination cluster, which is demo restore. Now we're going to go into the details of the workflow of our runner here. You can see we're looking at the TBK backup restore runner. We're going to have this configured so that it triggers the workflow every time a push or pull request happens on the main branch only. We're also going to make sure, for the case of this demo especially, that we can manually execute that action if we want. Our jobs are then going to be, in the case of a backup job first, as Prashanto alluded to, and then we're going to do a restore next. Here's a few checks and steps that's going to go through as it starts that backup process, making sure kubectl is installed, pulling those environmental variables. We're then going to create the manifests of our backups themselves, and you'll see those will be in the runner backup plan YAML file. And that backup plan will be named runner backup plan. We're then going to create the manifest for the backup itself, runner backup YAML. And the name of this backup is going to be runner backup. And we'll see that once the action is complete back in our source cluster. We're then going to make sure that we wait for any other existing backup to be completed before we start this backup. And then from there, we're going to execute the backup plan and backup itself, create them, and thus kicking off the backup. Now, the second part of our action, our second job here, the restore job. We're then going to do a few checks again, make sure kubectl is installed, these environmental variables, pull that from our .env file. And then we're going to create the manifest for our restore. And one thing I want to point out here is this storage class transform. Since we're restoring using Trilio from one cluster, a rancher cluster, into a secondary one, a OCP cluster running on GCP, they're two completely different distributions. So we need to make sure there's some consistency there when we do our restore. So this transform component is actually going to go into the backup and change the storage class. Before we had EBS SC for the storage class of our backup, and this new application is going to be running standard CSI for its storage class. We're going to check the manifest to make sure it's good to go. We're going to wait for that initial backup to be completed, that first job. And then from there, finally, we create the restore itself, and the restore gets off and running. Now I'm going to go into the actual action section, go down to my TBK backup restore, and go ahead and kick off this workflow. In just a minute here, you'll show it pop up on the queue. And here you'll see some details that the job is currently queued. It's going to show us what that total duration is once completed. And you can see here the two different jobs we have. First, our backup is going to occur, and then secondly, it's going to kick off our restore. So here's that series of checks that we talked about before in the workflow itself, making sure kubectl is installed, pulling that environmental variable. And then now is going to kick off creating that backup plan and backup. And now Prashanto, as I mentioned before, the backup itself in this demo is going to take about 2.5 minutes, maybe 3 minutes. And the restore itself will also take about 2.5 to 3 minutes. So at this time, if there are any questions in the chat or anything you want to address, Prashanto, I'll let you answer some questions there.
Sure. Awesome, Ben. Thank you for driving us through that. And yeah, we can see that the backup plan and the backup is getting created. So basically, this would mean that the production data is getting captured now, and we are moving that into that centralized repository.
Mm-hmm.
Right.
That's some great modularity in there. Just kind of thinking how the community can use that, like just being able. I love that anonymization piece you were talking about, because that was always a big struggle I had back a few years ago now at this point, with kind of you don't need customer data or any kind of identifiable information, not just there's some other regulation around that too. So that's a really big help as far as making sure you're treating data as it needs to be treated too through your workflows.
Correct. And then that is definitely one intricate piece. And as we were talking about the transforms, storage is one item that customers would definitely want to massage and tweak as they're moving the applications around. And then, these transforms are so powerful that anything and everything within your YAML file, you can technically tweak that as part of the overall operation. So in this runner that we have created, we have provided some injections for the storage class, provided some integrations for changing the service port and things like that. But users can actually, we have an entire API library of additional features, and they can actually use that entire API library to inject any kind of transform, any additional features, or things that they want to do as part of the capture and restore process.
To me, Prashanto, yeah, it really gets into how customizable the whole process is. Since we integrate natively into that Kubernetes API as well, you can really use the Trilio tool to build and change your backups and restores exactly how you want, especially in the example of those transforms you just said.
Great.
So there it looks like our backup job completed. And so
Nice.
now you can see the restore is kicked off. It's just going to wait here for a minute for the job to get picked up while it's looking for that runner. So it looks like it went through that series of checks. Checking to make sure that restore manifest is good.
Okay, that's great. Flowing very well. And while we were doing this, there is a question I see in the chat window. Do you have protected customer data in your production data that you are copying over to a test environment? So Ukachi, yes. So as I was saying earlier, when we are doing the capture, we have this feature known as hooks. And as part of hooks, you can actually start talking to the application directly and make sure that when you are doing a copy of that application, you can anonymize a particular table before that capture happens. So if there are any security and compliance reasons where you cannot bring production data back into your own environment, customer sensitive information, you can manage and handle that very easily with Trilio. Okay, and then I think the follow-up question is, if you have a way to anonymize customer data, then why not create synthetic test data that is customer alike? Yes, I mean there is the ability, and you could technically do that, but the point that we are trying to build on over here is that your production environment is continuously changing. There is new data that gets added, new type of data, new data forms that are getting added. That same data is being used by different microservices, and when you are injecting new variables into your code, maybe it may be a floating point integer, double point integer. Those typecasting issues are something that you can easily capture if you are constantly taking that production data and testing with it.
Yeah, it definitely makes sense. It could be also, situational dependent. Sometimes you can create synthetic test data, but it sounds like this is a really great way to continue as production data does change, making sure that you're continuing to test against those same data sets, so that you capture those defects further upstream. I mean, it's not just something here. That's something I think we can all relate with there.
Yeah.
Couple other questions I can chat. How easy is this to deploy from the chat from David?
So in terms of deploying the entire Trilio Vault solution, assuming you have a Kubernetes cluster and you can run a Helm command, it should take you about 5 minutes to deploy, configure, and get your first backup run.
Well, that's turnkey. I like that. Mm-hmm. Another one from Audrius. What's happening when production data is not 20 gigabytes, but a lot more? I've dealt with some customers lately. They told me that, some models they create can be upwards of 20 petabytes of data.
Correct. So one thing that we do is, we provide incremental captures as well. So let's say you did this, so the first time you got your production data in, and all your incremental testing activities can be based on the incremental captures, which will be overlaid on that base image that we already have. So that way you can continuously ensure that your data is current, and you're testing even however big your data size may get, you're still able to test with that. And this is going to be a key feature that we provide as part of the product in a few upcoming months.
So Prashanto, if I can chime in here now, as
Sure
hopefully you
thing.
all saw that restore completed. Do you want me to go ahead and finish up and show the pods running the new cluster?
Yeah, so let's do that.
Great. So here, first off, we're in the source cluster again, that Rancher cluster in the beginning. I'm just showing here that now we have that runner backup that has been completed. It was just done the past couple minutes here. It was a namespace backup and restore. This is how we chose to do it. This time was a namespace backup and restore, and we're available. And just as Prashanto said before, there are incremental backups that you can have to save space on your storage target, but here we did a full backup. Now going into our destination cluster, we saw that there were no MySQL objects running in this cluster before. Go ahead and take another look. And now you can see all 4 of those pods are up and running, our 3 front-end pods and our back-end MySQL. 1 out of 1, good to go, just created in the past 3 minutes there. We have our 2 services, our 2 deployments, and our 2 replica sets. We also have that persistent volume create in here, bound, good to go, just created about 5 minutes ago. And here you'll see, as I point out before, we switched from using one storage class in the other cluster to now using the storage class that is used in this cluster, that standard CSI. And once it was all in that restore manifest, that transform was inputted into there. There was nothing you saw that we had to do manually on our end. And then lastly, just to show you, we have the restore itself. Up here, runner restore, just as it was named in the workflow, is completed, just done in the past couple minutes here. And it was that namespace restore. And with that, I'm good with the demo, and I'll toss it back over to you, Prashanto.
Awesome. Thank you so much, Ben. I think that was extremely valuable. Especially doing it live. The demo gods were definitely with us, and I think it was presented in a very succinct fashion. Showing exactly what we spoke about in theory and you corroborating it in practice. I'm pretty sure it's going to be very valuable for our audience here. We can move back to my slides now. And I'll put this back into presentation mode. So in conclusion, what we want to say is that we all know Kubernetes is equal to all your microservices plus infrastructure as code, right? You want to make sure that you are managing your Kubernetes environments via infrastructure as code and not manually making changes. That's the recipe for success, and that's how you will be able to streamline your operations. Kubernetes focuses on application development and application delivery, and you need to ensure that you're using Kubernetes in this intelligent way, how we were showing, testing the production data, automating the entire workflows. You need to deploy these practices within your own environment to get the real benefits of a cloud native or Kubernetes environment. We've spoken about Trilio Vault being a purpose-built solution, managing your data and your cloud-native applications together as one unit. GitHub Actions, as we all know, are purpose-built tasks supporting CI/CD pipelines. And what Trilio and GitHub Actions together are providing you is the capability to continually test with production data to increase the software quality and delivery process for your customers. we are all aware of backup and recovery being used for day two activities, disaster recovery, migrations, and things like that. Now, today we have shown you how the same tool, via infrastructure as code and via GitHub Actions, can be used as part of your CI/CD or your DevOps processes. What we have shown you today can obviously be further extended. We have been hearing about DevSecOps. You can think about Dev Resiliency Ops. As you are deploying your applications in environments, you want to make sure that they are protected as they are getting deployed as well. So with the power of infrastructure as code, power of Trilio and GitHub Actions, you can make that possible as well, so that your application is protected right from the time it lands into production, and you're not really waiting for your operations teams to focus on those items. So with that, we conclude our presentation. We definitely thank you all for your time and paying attention to what Trilio had to present. We will be available to answer questions right after. And if there are any questions even after the session, you can reach out to us. My name is Prashanto. My last name is Kochavara. So prashanto.kochavara@trilio.io and ben.morrison@trilio.io as well.
Looks like we do have a question for you, PK and Ben.
Sure thing.
From Ravi, how do we ensure application consistency? Is that done via hooks?
Yes. So via hooks is the exact way to get application consistent backups. What we have done ourselves is we have qualified a bunch of different databases like MySQL, Postgres, Mongo, Cassandra, you name it. All these different databases, they've been qualified, validated, and we have provided the exact YAML files and everything that you would need to use directly in Gitbooks, which is our public documentation.
Oh, so just like an Action Marketplace, where they'll likely be able to find this GitHub Action, they can pull that information together for themselves.
That is correct. So one of the things we are doing with whatever Ben has provided and spoken about and the demo he did, we will be working with the GitHub team to host it as a solution that customers can leverage directly from GitHub. We will host it internally as well, and we will continually be updating it with additional features and providing a own custom module that we build. But obviously, developers and SREs are free to build their own modules leveraging the Trilio solution.
No, it's an open. I'm guessing the Action's an open source repository. So if anybody makes an enhancement or interesting things like that, pull requests are welcome on that.
Exactly. We will. We have it right now in a private repository, but we will be exposing that. We will be making some noise around that, evangelizing that. But yes, the end goal is to make sure that it's an open source model, so that we provide the starting point, and our users can keep enhancing that, and have that community involvement to make sure that life is simple and easy.
Awesome. Sounds great. Don't see any more questions in there. No, this has been great. Definitely been enjoying working with the team so far to date, and definitely this solves a myriad of questions. I now deal primarily with our advanced security stuff, but really helping folks as they're rolling out GitHub Actions. This is really that next generation level of problem folks are now, and now they have a best in breed solution to do that right native on GitHub Actions. This has been great.
Absolutely. Thank you, Moose. Thank you for the kind words. And I'm pretty sure there will be additional innovative methodologies that we'll all come up with. Trilio will be coming up with, and we'll be more than happy to work with the excellent team at GitHub and add more value to the IT world in general.
Awesome. Thank you all.
Thank you, everyone.
Thank you, Moose.
Thanks, Moose. Take care.
Cheers.